All right, welcome to the weekly RGW meeting. First on the agenda is from Matt about notifications and SNS topic policy. What is that?
I can't remember where you discussed this. I think we discussed it at the last refactoring meeting. I don't think this is the right meeting to discuss this. No, I don't think it's the right date to discuss all this. There's newer policy that I think in the last of these meetings we were talking about this one. It's another type of, this is a type of policy which I don't think you can use the SDK to submit, but the AWS console has it. And there are some other things like that. Lake Formation has a site control policy, I think it's called. We'll probably, which is something that's like a fine-grained default set of IAM policies, which I think we will eventually want. I don't want to waste people's time just sort of brainstorming about it, but I think we're going to want to add some of those things. If we don't have an API that's from tooling to support that, we may want some other path. Maybe the dashboard or something to set them, or maybe one in our APIs with extensions.
Okay, so these are IAM policies like bucket and user policy, but
Hello?
yeah, hi, did you hear me?
You stopped, you got cut off, I thought, for me.
Yeah, same for me too.
Okay, these are just normal IAM policies like the existing stuff we support, but they're just global in some way. Is that right?
Well, topic policy is like who can do what to what policies for topics, and site control policy, yeah, is another type of cross-cutting set of policy.
I think for topics, there's, I mean, this is part of the SDK. Shouldn't be any specific issue there.
This one might be. I'm pretty sure SCP or site control policy is not, but okay, I wasn't sure.
Yeah, I've looked at that because there was this was one of the requests from Krunal and the others.
That's why I mentioned it. I mentioned it because it came up. But so if we have a plan to implement this and it's straightforward to do, that's all. There's nothing
Yeah.
that's with regard to that one.
Yeah, it should be straightforward and pretty much copy and paste from the bucket policies. Of course, for different actions, yes.
No one else is particularly interested in site control policy. I'll bring up something with it in the next couple months or something as we try to frame up things that will use it.
Okay, yeah, it seems like maybe a Rados GW admin command and admin API to set it if there isn't a standard IAM or S3 REST API already.
I mean, for topic, it's standard SNS API, but we already use SNS API for setting the topics. So,
Right, but for the service control or site control one.
ever.
All right, any other thoughts on this?
Yeah, sorry. I guess I used the wrong word again for that one. Service control policy.
All right, next on the agenda is Yuval about performance of persistent notifications.
Yeah, this really came as a PR. I mean, I don't think that the people that did the PR are here, but at least I'm going to present what they suggest and my reply, just to make sure that the rest of the people here think that my replies are okay. Currently, we have, when we're doing the persistent notifications, we have our own thread that like going queue by queue or topic by topic, and each topic is locked to an RGW, and the queue kind of reads a bulk of notifications from the queue and send it over to Kafka or NQP. Both are asynchronous protocol. So you don't wait for the reply. You send as many requests as you want, and then asynchronously get a reply. You match them up with the transaction ID or something like that, and whenever and then you delete stuff from the queue based on the acts that you get in the reply. So this is how the mechanism works. Now, one of the things that they thought there is to give. So currently we have like a single worker, so a single worker thread that does the reading from the queue and putting that in some kind of an internal in-memory queue towards MQP or Kafka. And they were wondering why not add more workers there. So kind of my, I mean, I'm not sure whether adding more workers would give better performance, and I suspect that it probably won't. The reason is that the thing with notifications is that when you write to the queue, you write for each operation, for each S3 operation, you have one Redis operation to the queue. So depends with the size of your S3 operations. I mean, it could be a significant overhead to write to the queue. Reading from your queue, like by default, I think I read 1,000 notifications from the queue. They're not so huge, though. Average size of notifications is about 1K. So if I read 1,000 notifications, I just read like 1 meg from an object. So that should be like pretty quick. And then I just put that in the internal memory queue, which is again should be much faster than any Redis operation. And later on, it's being sent from a different thread that does the let's see, the Kafka management, but that's also pretty fast because again, it's a binary asynchronous protocol, so it is pretty fast. So adding multiple workers, I don't think would save us from the bottleneck of notifications, which is currently in writing into the queue. So that's kind of the main my main argument there. But if like I'm not even 100% sure. So if I have only a small number of queues, then I mean each queue it's one object, and the CLS operations of reading from the queue would be serialized anyway, even if I have multiple threads. So I'm not sure that's going to be very, very efficient. But if there are any other thoughts about that, I would be happy to hear.
Right. So this is talking about the notification manager's thread, which
Yeah.
is spawning ASIO coroutines and doing everything async, right?
Yes.
So, I mean, we already have concurrency there, so I don't see how adding more threads really increases concurrency unless this is so heavily loaded that it becomes CPU bound. But I don't believe that would be the case at all. So I mean,
Yeah.
unless we have reason to believe that there is a bottleneck in the single threaded version, then I don't see why we would need more threads there.
Okay. Yeah, that was what I was thinking as well. I mean, especially that there's very little work that's being done there. It's like reading from the queue, which is heavy, but this is Redis work. It's I/O, and then whatever we read, we parse and put it somewhere else, and that's it. So, and because the reading is done in one big bulk, then this is usually not the bottleneck for the whole thing.
So, I mean, if there was a bottleneck here, how would we see it? It would just be that the queues keep growing and we're not burning them down enough.
Yeah,
Is there some way that we can measure the size of the queues in some workload and verify that they're not growing?
So kind of two things. First of all, if the queue grows, then eventually it would fill up, and then the operation will start to fail. Because the first thing I do in the operation is try to make a reservation on the queue, and if I don't have enough space, I just fail and reply busy something to the client. So this is highly visible. And also, Ali Marsawa just added not so long ago a Redis Gateway admin command that gives you the size of the queue and the number of entries in the queue. So you can run the command and see what's going on. The thing is that the queue can fill up in two scenarios. One scenario is where what you just said, that we're not emptying the queue fast enough. The other scenario is that because when we read from the queue, we don't empty the queue. When we read from the queue, we're just sending the request. We're emptying the queue whenever we're getting the ACKs. So it could be that emptying the queue is really fast, but maybe the Kafka broker is slow, or there's some issue, or down, or whatever, and then we're not cleaning the queue, and the queue would build up and eventually fail. But this is not because we're emptying it fast enough. So again, it's pretty unlikely that that's going to be the bottleneck. I'm not sure what kind of other mechanism we can have.
Is there a way to tell which one might be happening? Like we're reading from the queue, or Kafka endpoint is slow, so that we don't get the callbacks in a timely manner. Is there a way to tell which scenario is happening when the queue becomes full?
I guess a good way of doing that would be to add some more stats to the, let's say, to the Kafka library. The previous, so I mean, to our implementation there, we can add more stats. We can measure like Kafka latency and so on. And I mean, this would be useful anyways, right? Because it would tell us what's going on in the system. I guess by adding those stats, we would know. So if the Kafka latency is low, then and still the queue fills up, then we might think that the problem is that we're not emptying it fast enough. But if we see a correlation between the Kafka latency and the fact that the queue is building up, then this is most likely a problem. We can add maybe, I think we can add maybe another stat that tells us how many Kafka requests we're having flight. That would give us, again, a good indication. Like if we have lots of things in flight and this builds up, then it means that it takes us lots of time to clean up the queue, and the queue would build up as well. So that could be another option. So I guess adding more Kafka stats would give us the better understanding of what's going on there.
Yeah. In terms of this threading thing, I have trouble believing that it's going to be a bottleneck, but I mean, the PR itself, the change is really minimal. The ASIO model makes it easy to add more threads, and everything is thread safe anyway, since it's just using Rados requests. So I don't necessarily object to supporting more threads as long as the default stays as one.
Yes, the thing is that, well, kind of my worry is that, people would see that the system has an issue. They would start seeing like busy messages on the client, or they would call the command and see the queue builds up, and they would say, oh, let's add more threads. And that won't solve the issue. It might even worsen the issue, because again, there'll be like a couple of CLS requests competing on the OSD. I'm not sure if this is really could be an issue or not, but for sure that won't make things better.
I think a good test would be to have a Kafka endpoint that instantly returns, like a mocked Kafka endpoint. Do some kind of integration test,
Mhm.
And that under high IOPS, we make sure that Kafka endpoint is not bottleneck. It returns immediately the callbacks,
Mhm.
and see whether one thread or multiple thread makes any difference in terms of queue size. That would be
Right.
the ultimate testing, perhaps, to see whether single thread is not the bottleneck anyways. So
Yeah, well, I guess what you would see in this case is that, I mean, in order to really get to a scenario where it might be better to use two threads is if you have just one queue, one topic, you have a very large number of RGWs. So I don't know, let's say 100 RGWs, which means that you're going to have 100 RGWs writing to the topic at the same time, and only one reading from the topic. And this might give you a little bit of stress on the reader. But even in this case, I'm not 100% sure that that would be a real problem.
I mean, if it's one topic though, then the reader is still just bottlenecked on Rados, right? To list things and, well, bottlenecked either on Rados or the
Right,
message broker. It's not going to be CPU bound.
right. Yeah, so even in this case, even in a very extreme case like that, I don't see how it helps, because again, if you have two threads, they're just going to be serialized on the CLS commands that's reading from the queue. They're not going to do the thing really in parallel, right? Because you can just do one CLS at a time.
Another question, would reducing the default reservation size down from 4K, I think, which is the default, to let's say 1K, would it improve performance in any way? Or are there any downsides?
Well, so I mean, it's a single object, so it's all writes and reads to the object. The reason I chose 4K is because when I'm doing the reservation, I don't know exactly what is the size of the notification. So as I said, usually notifications are 1K. It could be bigger because of all kind of variable strings that may exist there. So I'm using 4K to be on the safe side, because the worst thing I want like what I want to prevent is that I made a reservation is okay, and then all of a sudden the notification is much bigger, and when I'm doing the commit, I'm failing, because when I'm failing the commit phase of the writing to the queue, there's no rollback. So when I'm failing a commit, I'm in a bad state, which means that the operation was successful, notification was never going to be sent. When I'm failing the reservation, I'm good. Like, reservation failed, the S3 operation never happened, and it's all good. So this is why I'm trying to kind of, take lots of extra space there to make sure that this doesn't happen. But this is the reason I'm using the 4K, just to make sure that if the reservation is okay, then for sure the commit would be okay.
Okay.
It won't change performance. I mean, the only impact is that it would change how many notifications could be in the queue. So if you have
Right.
like 1K notifications, you can have much more, but you're gonna have like only 25% for that, because you're making the reservations. And I mean, if the queue fills up eventually, so it's like it's going to be less efficient. So it's all about the efficiency of utilization of the queue. It's not about performance.
Okay, makes sense.
Yeah, so I think, again, sorry, my takeaway here is it's probably to add more stats to the Kafka part, to the Kafka client, which is a good thing. It's like, it should be done anyways, and would also give us kind of even more insight as for where the issues are.
Sounds good.
Okay, thanks.
All right, any other thoughts on notifications in general? Then last call for new discussion topics. All right, we'll stop here then. Thanks, everybody. See you next time.